So today I'm going to be talking about the molecule saccharin. It consists of 5 hydrogens, 7 carbons, 3 oxygens, 1 nitrogen, and 1 sulfur. It also has 12 single bonds and 6 double bonds. Its molecular weight is 183.19 grams per mole, and its density is 0.828 grams per centimeter squared at 25 degrees Celsius. It's a solid white crystalline powder or white crystals. It has a very sweet taste. In dilute aqueous solutions, it's about 500 times sweet as sugar, and it has a bitter metallic aftertaste. Its melting point is 226 degrees Celsius, and its boiling point is 545.83 Kelvin. Its solubility in water is 100 milligrams per milliliters. In its acidic form, saccharin is not particularly water soluble. In salt forms, it's very water soluble. In 2 to 7 pH, it's stable, and it's stable in temperatures up to 150 degrees Celsius, so it's stable at room temperature. When heated to composition, it emits toxic fumes such as nitrogen, sulfur, and sodium oxides. Its heat of combustion is 4,753.1 calories per grams. Its pH of 0.35% aqueous solutions. It's used as an artificial sweetener in so many foods. Its main 4 forms are acid saccharin, sodium saccharin, potassium saccharin, and calcium saccharin. Sodium saccharin is the most used form because it's highly soluble, it's stable, and costs not much to produce. Saccharin is the most economical of the high-intensity sweeteners. It's absorbed slowly, not metabolized, rapidly excreted by the kidneys, highly stable, has a long shelf life, and it's suitable for cooking and baking. It also does not promote tooth decay like sugar does, and it's suitable for diabetics. It has a bitter metallic aftertaste, as I said earlier, and it's even more evident at higher concentrations. Because of this, efforts have been made to mask the aftertaste by adding substances such as cream of tartar, lemon flavor, pectin, ribonucleotides, glycine, gentian root, and artificial sweeteners such as aspartame and cyclamate. Combinations of saccharin with aspartame or cyclamate have proved to be very successful for this, especially in masking the flavor. Saccharin aspartame concentrations are commonly used in the USA in diet soft drinks. Saccharin is also found in a wide variety of diet foods and other drinks. It's also used as a common table sweetener. It's sold under the brand names Sweet and Low, Sweet Twin, Sweet and Low, and NectaSweet. Saccharin is available in either granule or liquid form, with 1 serving providing sweetness comparable to 2 teaspoons of sugar. Another common source of saccharin is artificially sweetened drinks, but the FDA restricts this amount to no more than 12 milligrams per fluid ounce. It's often used in baked goods, jams, jellies, gums, canned fruit, candy, dessert toppings, salad dressings, and more foods. It can also be found in cosmetic products including toothpaste and mouthwash, common ingredients in medicines, vitamins, and pharmaceuticals. Sodium saccharin is the common form of saccharin that is used in food and toothpaste. It was discovered in 1839 by Ira Remsen and Konstantin Fahlberg of Johns Hopkins University. Fahlberg, using benzoic sulfamide for a coal tar derivative, tasted his fingers, and that's how it was discovered. Since the early 1900s, it's been commercially used, so it's been produced commercially in the United States for over 80 years. The safety was questioned in 1977 Canadian study, which found bladder tumors in male rats, given unrealistically high doses. In the USA, the FDA proposed a ban on saccharin in 1977. All scientific research conducted since then has shown that this effect is only seen in male rats at extremely high doses, and has supported the safety of saccharin for human use at the levels currently consumed. Several human studies have shown no overall association between saccharin consumption and cancer. The ban was formally withdrawn in 1991, but saccharin in foods and drinks containing saccharin were still required to carry a warning label. But in 2000, legislation gave saccharin a clean bill of health and finally removed the label. Until 2002, saccharin was classified as an unreasonably anticipated carcinogen in the United States. Saccharin was finally removed from the carcinogen list in 2002. Saccharin appears to be generally safe for consumption and is an acceptable alternative to sugar. What happens when you drink Diet Coke? Nothing. You might just lose weight if you drink this instead of full sugar Coke. Artificial sweeteners have been shown consistently safe for human consumption. You may not lose weight, but you're more likely to lose weight if you use a sugar-free method instead of sugary drinks. Saccharin is often recommended as a sugar substitute for people with diabetes because it's not metabolized by your body and does not affect blood sugar levels like refined sugar does. Is it a hero or a villain? Depending who you're talking to, it could be both. In my opinion, I believe it is a hero compared to sucrose. Saccharin is a zero-calorie artificial sweetener. It's 300 to 700 times sweetener than table sugar and commonly used to replace it. So it leads to reduced calorie intake. That makes it a hero to me. And here are my sources. Thank you.